Hello, my name is Amr Kilic. I'm a PhD student at the University of Edinburgh, and I'm happy to present our work titled DLAMA, a framework for curating culturally diverse facts for probing the knowledge of pre-trained language models. This work has been done under supervision of Walid Magdi. It has been previously shown that for MBERT, Arabic prompts have half the ability of English prompts to recall facts. And to explain what we mean by recall facts, if we start with factual triplets in the form, for instance, Ottawa and country and Canada, with multiple versions in English and Arabic, we can transform these triplets into prompts, taking the shape Ottawa is located in, and then dots, or as a corresponding Arabic prompt as well. And the model is basically asked to fill the gaps with the appropriate answer object. And that's how we kind of approximate the factual knowledge of models or probe for such knowledge. So possible explanations that were provided are that MBERT's pre-training data are less representative of maybe Arabic facts or Arabic language in general. Maybe the quality of the probing prompts deteriorates with languages like Arabic. But we also want to raise attention to one overlooked explanation, which is the representation bias and the benchmark, which was MLAMA in that case. So to quantify this benchmark, we identified 21 Western countries, and we found that for both LAMA and X factor, which are factual knowledge benchmarks, about two-thirds of the triplets within these benchmarks belong to the 21 Western countries, as opposed to the rest of the triplets, which belong to the rest of the world, which is kind of a clear skewness in the benchmark. So we propose the DLAMA framework to build better and more culturally diverse benchmarks. For the first version of our benchmark, it has three splits of contrasting sets of facts, namely Arab and Western facts or countries, or facts related to these countries, facts related to South American versus Western countries, and lastly, Asian and Western countries. And we provide parallel labels in Arabic and English, Spanish and English, and Korean and English, respectively, with a total of more than 78,000 triplets covering 20 Wikidata predicates. So to explain the framework and how it works, we provide an example. So if we have the predicate P27 on Wikidata, which is the country of citizenship, that has the subject person and an object as country. And for this example, the countries of interest are just the US, and the languages of the labels are both English and Arabic. So through a Python interface, these query parameters are set, and they are used to generate a Sparkle query that's used to and sent to Wikidata. So we get Wikidata URIs in the form of subject and object URIs, and then we augment these information or triplets by first the links of the Wikipedia articles for these subjects in both languages, in Arabic and English. And we find the maximum of the article sizes for both articles for each triplet. And then we sort the triplets by the article size descendingly, and we found that generally triplets that have larger article size are more trustable, are more truthful than actually triplets that belong to articles with smaller sizes. And lastly, we get the parallel multilingual labels for these triplets, and then we truncate the list to the top K. And for our benchmark, the K is the first 1,000 triplet for each predicate. So for the results, we will just show an example of how when the underlying facts change or represent different countries, the model's performance change. And we generally contrast the performance of an English model, which is BERT-based on English prompts, and compared to other monolingual BERT models. For this case, it's RBERT, which is an Arabic BERT model. And we found that generally the English model for this example performs better on the Western facts, as opposed to our BERT, which performs better on facts related to Arab countries. And for the South American and Western pair, we found that both the English model and the Spanish B2 model perform better on the Western countries, which might hint that actually both these models um, perform or have better knowledge of facts related to Western countries. And lastly, for the Asian and Western countries, we found that the Korean model performs better on the Asian facts, while the English model performs well on the Western facts and surprisingly performs better maybe on the Asian facts as well. And we provide more information in the papers regarding why this might be the case. So as we can see, the model's performance change according to the underlying facts, which raises attention that we should actually care about the benchmark's facts and not just assume we have a set of facts that are representative. So our main contributions can be summarized as that first, translating English factual knowledge benchmarks introduces a cultural representation bias. We also built DLAMA-V1, which is a benchmark of contrasting sets of cultures. And we show that we can have better model analysis thanks to the contrastive nature of DLAMA. Thank you very much for listening and looking forward to discussing this forward with you. Thank you.